Hi, this is King of Review. In this problem, we want to solve the system of linear equations by using Cramers Rule. So if we have two equations that are in the form ax plus by equals e and cx plus dy equals f, then we can use Cramers Rule to solve the system. That is, find x and y. Cramers Rule states that x is equal to the determinant of the x matrix divided by the determinant of the coefficient matrix. And likewise, y can be found by taking the determinant of the y matrix and dividing it by the determinant of the coefficient matrix. So how do we set up our matrices? Well, let's start by looking at the coefficient matrix. The coefficient matrix, for the entries, we're going to have the coefficients of the x and y terms. So A, B, C, and D. The x matrix, we're going to start with E and F. And if you notice, E and F are the constants in our two linear equations. And then we have B and D. And the y matrix, this has A, C, and then E and F. So this is how we set up the matrices. So let's fill them in using our specific values. The coefficient matrix. Let's look at our system here. We have the coefficients -2, 4, -2, and 1. So -2, 4, -2, and 1. And now let's look at the x matrix. We start with E and F. These are the constants. So 1 and -3. And then we have B and D. And then the y matrix is A and C, so -2 and -2. And then E and F, 1 and -3. So now we've set up our matrices. Now if you look at Cramers Rule, when we solve for x and y, we need the determinants of these matrices. What is a determinant? Well, a determinant is a real number that's associated with a square matrix. So let's say we have a matrix A, B, C, and D. If we want to find the determinant, we'll take the product of the entries in the main diagonal, so AD, and then subtract the product of the entries in the other diagonal, CB. So AD minus CB, this is how we find the determinant. So let's find that for the coefficient matrix. We're going to take the product of the main diagonal, so -2 times 1, and then subtract the product of the entries in the other diagonal, -2 and 4. And so when you work this out, this equals 6. So 6 is the determinant of our coefficient matrix. Now let's find the determinant of the x matrix. The product of the main diagonal, so 1 times 1, minus the product of the entries in the other diagonal, -3 and 4. And when you work this out, this is equal to 13. And now for the y matrix. We're going to take the product of the main diagonal, so -2 times -3, and subtract this product, -2 and 1. And when you work this out, this is equal to 4, or this is equal to 8. So -2 times -3 minus -2 times 1, that gives you an 8. So 8 is the determinant for the y matrix. So now let's solve for x. We'll take the determinant of the x matrix. We solved for that here. That's a 13. Divided by the determinant of the coefficient matrix. That's a 6. So we have 13 over 6. X is equal to 13 over 6. And now for y, We'll take the determinant of the y matrix, that equals 8, and divide that by the determinant of the coefficient matrix, that's 6. Now let's reduce this fraction. We have 4 over 3. So y is equal to 4/3. So now we've solved our system. We've found x and y. Letter B is correct. Thanks for watching.